Humanity's gaze has always been drawn upward toward the night sky, toward the vast unknown that stretches far beyond the reach of imagination. For countless centuries we have looked into the cosmos with awe, curiosity, and a persistent desire to understand what lies beyond our world. We believed that with patience, careful observation, and reason, we could decode its rhythms, measure its distances, and uncover its hidden order. We charted stars, traced planetary motions, mapped galaxies, and gradually built a picture of a universe governed by laws that seemed increasingly familiar. Yet every time humanity believed it had reached the edge of understanding, the cosmos revealed another layer beneath it, more intricate and more mysterious than before. Now, with the arrival of the James Webb Space Telescope, that pattern of discovery has accelerated beyond anything previously imagined. This observatory, with its enormous golden mirror and extreme infrared sensitivity, has allowed humanity to peer deeper into space and further back in time than ever before. What it has revealed is not just a collection of distant objects, but a universe far more complex, dynamic, and structured than our previous models suggested. Webb is not simply an upgrade over earlier telescopes. It is a fundamental shift in perspective. Where earlier instruments showed us a universe populated by distant points of light, Webb reveals a layered cosmic history, one that stretches back over 13 billion years, into the earliest stages of cosmic formation. It is a machine that does not just observe space, but time itself. Before Webb, the Hubble Space Telescope transformed our understanding of the deep cosmos. Its famous deep-field images revealed thousands of galaxies in a patch of sky so small it seemed almost empty. Each faint point of light was revealed to be an entire galaxy, containing billions of stars and planetary systems. From those observations, humanity began to understand that the observable universe may contain hundreds of billions, perhaps even trillions, of galaxies. But Hubble had limits. It could not fully detect the faint infrared light from the earliest galaxies, whose signals had been stretched by the expansion of space. That early cosmic light, originating only a few 100 million years after the Big Bang, remained hidden from view. Webb was designed specifically to uncover that hidden era. Its infrared instruments can detect the faint glow of the first galaxies as they began to form. When it opened its gaze to the universe, expectations were high, but the results surpassed even the most ambitious predictions. One of its most significant deep-field surveys mapped a region of sky containing hundreds of thousands of galaxies. The resulting image is not a simple snapshot, but a layered record of cosmic history. Some galaxies appear young and chaotic, while others already show surprising structure and maturity. Spiral arms, dense star clusters, and chemically enriched regions appear far earlier than conventional models predicted. According to established theories, early galaxies should have been small, irregular, and chemically simple. Heavy elements such as carbon, oxygen, and nitrogen were expected to appear only after multiple generations of stars. Yet Webb has observed galaxies rich in these elements at extremely early stages of cosmic history. This suggests that star formation and chemical evolution occurred faster and more efficiently than previously thought. Such findings challenge long-standing assumptions about how quickly structure can emerge in the universe. Instead of a slow, gradual buildup of complexity, the early cosmos appears to have developed rapidly, forming organized systems in a relatively short span of cosmic time. These galaxies are not isolated. They are embedded within a vast cosmic framework known as the cosmic web, a structure composed of filaments of dark matter and gas stretching across billions of light years. Galaxies cluster along these filaments, forming an interconnected network that resembles a vast three-dimensional skeleton of the universe. What is striking is the level of order within this structure. The distribution of galaxies and matter is not random, but follows intricate patterns that span unimaginable distances. This suggests that the universe's large-scale architecture may have been established very early in its history, shaped by forces and processes that are still not fully understood. As Webb continues to observe deeper regions of space, it is also forcing scientists to reconsider the timeline of cosmic evolution. The universe may not have developed as gradually as once believed. Instead, it may have undergone rapid periods of structure formation, where galaxies and large-scale formations emerged quickly after the Big Bang. This does not overturn the Big Bang theory, but it refines it. It suggests that the early universe was far more active and efficient in forming structure than current models can fully explain. The laws governing that era may still hold unknown variables or physical processes that remain undiscovered. There is also a growing realization that the universe we can observe may be only a fraction of the whole. While current estimates place the observable universe at about 93 billion light-years across, Webb's findings raise deeper questions about what lies beyond that horizon. If complex galaxies formed so early and so widely, it suggests that the larger cosmos may extend far beyond what we can currently perceive, possibly without a defined edge. Standing before these images, humanity is confronted with a paradox. On one hand, we are dwarfed by the sheer scale of the universe, with its hundreds of billions of galaxies and unimaginable distances. On the other hand, we are capable of building instruments that can look across that vastness and reconstruct the story of its beginning. We are small, yet we understand. We are brief, yet we can observe billions of years of history. The universe reveals itself not as a static backdrop, but as an evolving structure filled with motion, transformation, and complexity. One of the most profound insights from Webb is that galaxies are not isolated islands. They are interconnected through gravitational forces, dark matter filaments, and cosmic flows that shape their evolution. These connections form a vast system where matter is continuously redistributed, influencing the birth and growth of new structures across cosmic time. This interconnectedness suggests that the universe is not simply expanding in a uniform way, but evolving through dynamic relationships between its largest structures. Gravity, dark matter, and cosmic expansion work together to create a living architecture that is still unfolding. As observations continue, some scientists have begun to question whether current cosmological models fully capture the complexity of what is being seen. If large structures formed earlier than expected, and if galaxies evolved more rapidly, then the early universe may have operated under conditions that are not yet fully understood. These questions do not weaken our scientific frameworks, but instead push them forward. Each new observation from Webb refines our understanding and exposes new layers of complexity. The universe is not becoming simpler as we learn more. It is becoming richer, deeper, and more surprising. At the same time, Webb reinforces a profound truth about humanity's place in the cosmos. Despite our small scale, we are capable of reaching across billions of light-years to observe the origins of galaxies. We are able to reconstruct the universe's earliest chapters from faint traces of ancient light. This ability transforms our perspective. The universe is no longer just something we exist within. It is something we can study, interpret, and begin to understand at its deepest levels. In doing so, we become participants in its ongoing story of discovery. Every image captured by Webb is more than a scientific record. It is a message from the distant past, carrying information about how the universe began and how it continues to evolve. Each observation reveals both clarity and mystery at the same time. And as Webb continues its mission, one truth becomes increasingly clear. The universe is not a finished structure. It is an ongoing process, constantly forming, evolving, and reorganizing itself across unimaginable scales. For every answer it provides, new questions emerge. For every mystery it resolves, another appears beneath it. And in that endless cycle of discovery lies the true nature of science itself. The cosmos has revealed its earliest light, and yet we have only begun to understand what it means.